Excitement. You saw the title. You're like, wow, length of a line segment. Learning goal. Determine the length of a line segment. Pretty simple title. It seems impossible, maybe. Determine the length of a line segment, but I'll show you how. So, some stuff about coordinate geometry. A point is the location in space x, comma, y. Yes, good, got it. Second, a line segment, a collection of infinite points between two endpoints. What are they talking about? Let's just go over this line segment thing again, because I don't want there to be any doubts about what it is we're talking about here. There's a line segment. It has a beginning and it has an end. Unlike lines that we talked about, and in math, a line means it goes on forever. Line segment has a beginning and an end. So we can find its length because there'll be a point over here, x1, y1, which I hope you found out yesterday, wasn't just for slope to label these things, x1, y1, and x2, y2. When we have those 2 points, we're going to find the length of that line. Now, at first glance, it looks like, how are we supposed to find the length of the line without just getting out our ruler, which is not going to work for long lines or decimal lines or any of those situations. We need something better. Recall, though, some interesting information that I'll use. Collinear points are points that lie on the same line. Area of a rectangle is length times width. Area of a triangle is base times height over 2. Equilateral triangle is a triangle with sides of equal length. Isosceles triangle, 2 sides of equal length. Have you seen this before? Isosceles triangle? If you haven't, that's okay. An isosceles triangle just means you've got a triangle and only 2 sides are the exact same length. Have you seen the little lines before to say these are the same? Right. Equilateral, that means all 3 sides are the same. And maybe my equilateral triangle, or sorry, my isosceles triangle needs a little work here. Let's make sure it looks isosceles. Woo, woo, woo. See, only 2 sides are the same. And then a scalene doesn't have any sides the same. Slopes, rise or run. But the one I really want to talk about, this is all stuff that's going to come up this chapter, by the way. We're going to need that along the way. This is the one I need today to find length of a line segment. So let me just give away the whole lesson in one sentence. When you were doing Pythagorean theorem, you were finding length of a line segment. You called it the hypotenuse. It was a line segment that began and ended. You had both ends. Okay. Calculate the length of the line segment AB using the Pythagorean theorem. If you thought at the start of this lesson life was going to be very difficult, it's not. When I build the formula, it'll look weird. We're just going to do the Pythagorean theorem today. And if you don't remember the Pythagorean theorem, well, here's me reteaching it. When you're given any line segment in the coordinate plane, any 2D situation like this, and you draw a line segment, you can always turn it into a right angle triangle. Always. Immediately. Just turn that into a triangle. It would be the right triangle. And by the time you've done that, Pythagorean theorem's like jumping up and down on the bench ready to get in. Do you know what I'm talking about here? Little 7 and 8-year-olds that I coach. When it's their turn to go on, they're jumping up and down on the bench going, put me in, put me in. As soon as you draw that triangle, the Pythagorean theorem's like, yeah, I'm in. Sub me in here. What is the Pythagorean theorem? What is the Pythagorean theorem? Let me write it down. Write it down in its original form. The square of the hypotenuse is equal to the sum of the squares of the other 2 sides. That was what Pythagoras said. If you drew a square off of each side of this triangle and found each area, the 2 legs, their areas, would add up to the hypotenuse area. Shocking result, like unbelievable. And lots of easy proofs out there. By easy proofs, I mean, we could do them. We could walk through the proof and go, oh, that makes sense to me. But I'll save that up. We're going to do some algebra in, I think, Unit 4, which makes the proof so nice. I've got a beautiful proof of Pythagorean theorem. That's it in words. Does anyone remember the proof algebraically, though? The equation? A squared plus B squared equals C squared. And you can do it the other way around as well, and it doesn't really matter. He's right. I'm going to write it the other way around just because I know what's coming later in this lesson. So it's C squared equals A squared plus B squared, where I'm going to make a little modification. I'm going to do one of the steps for you right off the hop because I'm not really, I want to reteach Pythagorean theorem in this lesson just in case you forgot. I do want to do that. But I'm teaching length of a line segment, and for length of a line segment, we'll see it more like this. We'll actually move the square root over and say, okay, that means C is the square root of A squared plus B squared. That's not any different. You did those steps. You just usually did the square root at the end. I'll do the square root. I'll write it down at the beginning of these. Okay? All right. Now, how long are these two sides? I'm going to label this one over here A and this one over B, but it doesn't really matter if I exchange the A's and B's, but the C has to be the hypotenuse. That's one thing that has to be true. How long is A? 2 minus negative 4. She has a gift of jumping my lessons ahead in their thinking. Yeah? 2 minus negative 4. I'm going to write that down. Let's leave a space, okay? I'm going to write that down here. Leave a line. She says, do 2 minus negative 4. That is brilliant. She's seen through the whole lesson. There's one little problem. That's the B, isn't it? Let's move it over. That's the B. Two minus negative 4. That's the B. So true. 2 minus negative 4 is B. Is that what you were thinking for B? Does anyone look at B and look at that and say 2 minus negative 4? No, probably not. Most of you looked at that and said, oh, 1, 2, 3, 4, 5, 6. Yeah? So let me write that over there. C equals square root, most of you would have gone 6 squared. I agree with that. That's how I was going to do the example until she said that brilliant thing. Okay? I'll get to her brilliant thing in a second. For now, just look at this and go, yes, I see that. B is 6. How long is A? 8. Hopefully you can just look at that and see that's 8. 1, 2, 3, 4, 5, 6, 7, 8. I can count. But that's not what you're going to say, is it? What are you going to say?
-4 -4.
She's going to say -4 minus 4. Now let's not, I'm enjoying the mystery here about what's going through her brain. Let's just see if she's right first, shall we? Then we'll try and explore what it is she's saying about this situation. Is 2 minus -4 equal to 6? Yeah, it seems like she's onto something here. Is -4 minus 4 squared the same as 8 squared? Well, yes, once you square it. -4 minus 4 is -8. When you square it, it becomes positive 64. So what she said is going to work. Let's find out if she can explain it, though. Why did you do for, we'll do the B first. She took the 2 and subtracted the -4. I'm interested in the words you use, because maybe she'll need some help on the words, but maybe not. Why did you take 2 and subtract -4 to find the length of B?
I found it because if I try to count it and it was like a larger number, it'd be hard to count every single square.
She's all over it. She says, and let's forget about the decimals for now, because it's also true for decimals. And we talked about that yesterday. Graphing, not the greatest for decimals or for large numbers. So her example was for large numbers. If these numbers were large, counting would be out. If this was 2 million, and this was -4.7 million, you're not going to count the individual ones. So she says, what I want, and I'm going to add one word for you, okay, that I think is going to help you. She says, what I want is the difference between these x values. The delta x. That's what that is. B is delta x. It's how much x has changed. And the A is delta y. And there's the breakthrough in the thinking here. It's like, oh, it's the same as slope. I need delta x and delta y. The only difference is, once I have delta x and delta y, I've got to square them. And these lines have turned into all the wrong order, which I actually really like about this lesson here, is that this is going to be c equals x2 minus x1 squared plus y2 minus y1 squared. If this question was on the test, would you use this fancy new formula? No, I don't know. You don't have to. You can just count the squares. This formula is now ready for any points. Decimals, no problem. Big numbers, like she said, no problem. Big numbers with decimals, no problem. This formula can handle all of those situations. But all the way back here, what's 8 squared? 64. 6 squared is 36. And then this one worked out nice. Square root of 100, which is 10. The length of this line segment is 10. What did I use? The Pythagorean theorem, really, is all I used. But to get ready for tougher points, we've now got this, and I want to highlight one line for you. If this is all running together and you're like, oh, well, you made a big mess of this example, Mr. Todd. Well, yeah, I suppose I did, but this is the two lines I want you to highlight. That's how this lesson refers to other lessons. The delta x is your A, the delta y is your B, or those are B and A, whatever way around you want to talk about them. Okay? Giving away most of the lesson. We hammered it through there. We handled all the situations. All that was supposed to be in this example was 8 squared and 6 squared, square root of 100, 10, done. But she took us off track and, well, actually, on track. She took us to where we have to go. Any questions about that? Wonderful mess. Wonderful mess. All right, well, we got there. After all that, can I just look for a second? Oh, I see. Okay. So the Pythagorean theorem is used to develop the formula for distance between 2 points. We will use the line segment that connects A to B. And now it's got 2 points on there. And I wish it didn't have the scale on here, actually. Ignore the scale for a second. This is true for any 2 points now. For any 2 points, if you want the length of this line segment, what you're going to do is you're going to go, okay, the A, and I'm going to label it the same as I did in the last one. Did I put A along the side? Yes. A doesn't have to be along the side. But I'm going to put it along the side like I did in the first one, just so nobody gets off track here. And the B here. The B is the delta x. The A is the delta y. So if that line's confusing to you, use this one instead. And if you're right with me, you're like, okay, y2s, y1s, x2s, x1s, I know what all those mean in a question, then that's the end of it. Now, usually that's called L now. So my last line is the official formula, which I'll put on the next page in just a second. Usually we put the x's first, but it doesn't matter. Whether you do the x's or the y's first. There's what we call the length formula. That's how you find the length of any line segment in 2D. And better yet, it's how you find the distance between any 2 points in the Cartesian plane. Now, that might present a problem because it could be you're like, I totally understood the midpoint formula and I had it memorized. I got it completely. But now when you put a new formula, my brain now has these 2 formulas bouncing around, and now to keep track of the 2 is a bit of a problem. So there's a little bit of memorization of this chapter to go, which formula does which thing, even though on each day you feel confident about the particular formula. So you're going to have to do a little memorization to make sure you have the right formula in your brain as we go along. Do you need more time there? Here it is, sometimes also called the distance formula. So you can use D here instead. And it just looks like this. The distance is also the length of the line segment AB. So I know I just called it L, and then I switched and called it D, and both are true. Make sure you have that copied down. And I'll just remind myself of some things we got to talk about afterwards while you're copying that down. That was just some notes to myself of things I got to talk about today. Once I finish the lesson, how am I doing? Page 5 of 7. Ooh, not much more to go, apparently. Got to try this thing out. Got to take it for a test drive. I see some of you have already jumped ahead and done that. Do you need more time to copy this down here? You okay? Tried to give you some time there. Calculate the length of a line segment. Okay, please, please, friends, do this. Even if you were so good at x1, x2, y1, y2 before with slope, for a while, just till you're sure it's going to go well. Anytime you get given a question now, label these. x1, y1, x2, y2. That is going to be extremely helpful as you learn the new formulas. And like everything in math, sometimes when you learn something new, you got to be a little careful about the old stuff. And that's what I'm doing here. Let's be a little careful about the old stuff. It says calculate the length of the line segment. So then I need to know the length formula equals square root. It's just the Pythagorean theorem. This is just the Pythagorean theorem. I got to find x2 minus x1, and then square it, and y2 minus y1, and square it. I'm going to make a note about this as I go to convince you this is just the Pythagorean theorem in just a second. And I'll say it, because I believe it, in this chapter. If you label your points, and you know the formula, the rest is straightforward. Yes? Sub the numbers in. x2 minus x1 and y2 minus y1. And then check. I find it easier to check after I've written it down. So I just write it down. I don't worry too much about getting it right. And I just check to see if it's right. 3 minus negative 2, yes. And negative 6 minus 4, yes. 3 minus negative 2 is 5, and negative 6 minus 4 is negative 10. And then do yourself a favor. In spring green, because it's such a nice day out, right underneath this, that's the A, and that's the B. That's just how long the A and the B were in the triangle. You can look at it and see. It's got a great check in it. Look at it. Negative 2 to 3. How far is negative 2 to 3? If you were jumping along like a little frog in a number line, how many jumps is there from negative 2 to 3? 5. That's how far away those two x values are. How far away are these two y values? 4 and negative 6. If you had to do a frog jump, from 4 to negative 6, you jump 10 times. You're like, what about this negative? Pythagorean theorem's like, settle down. It's going to be all right. I know it's a negative, but watch, I'm going to square it. So the squaring takes care of whether it's positive or negative or not. So it's built in there. It's like, it's okay if it comes out to be negative. We're going to square it anyways, and we'll get the true squared length. So this is square root 125, which is not a whole number. And that's one of the good news about the length formula, is it handles decimals, lengths, no problem. We can find the length to whatever decimal places we want. Square root 125, I get 11.18. Usually in this class we'll do one decimal place, but I did 2 just so when you type it in, you can look at it and go, I agree. I also got 11.18. And I put a little dot. Did you see me put the dot over top of it? Did you do that in grade 9? Little dot over top tells me I rounded off. It wasn't exactly 11.18. When I looked at my calculator, it was 11.1803399. So when I put the dot over the top, I'm letting people know I rounded this. It's not perfect. I rounded it. In future grades, we'll leave it just like this, so we don't have to round. It looks weird, I know, but we'll just leave it like that and use it to do whatever we want to do next. But for now, decimals is fine. Any questions there? Slide 6 of 7. One more to go. Do you need more time there? Is it okay? This is getting closer. I warned you yesterday. I said, listen, we're going to do some lessons that might seem pretty easy, and then things are going to get real. Okay? This, again, the last example is to give you an idea of how things might get real dealing with all this. The points L, 3, 0. Okay, let me put that on there. L. M, negative 2, 5. Okay. And N, negative 5, negative 1. Got those all on there. Are the vertices of triangle LMN. So that's a triangle. All right, so let me get my straight line tool out, and I'll connect those up. Dots in green, lines in red today. And let me just check all those points. I don't know if you've ran into this before. Copying errors happen so easily. So the first thing you should always do is check to make sure, did I get that right? 3, 0, yeah. Negative 2, 5, yeah. Negative 5, negative 1, yeah. Okay. Sketch LMN on the grid below. Check. I like putting little check marks beside the stuff I'm done. So I feel good about it. I'm done A. B, calculate the length of each side to 1 decimal place. So we're going to go through, and we're going to do the length formula 3 times. I'll do the first one with you, and then you try the next 2. Okay? So you get another practice one, and then 2 to practice on your own. And then, I don't know, see what you see to try and do letter C. You see? You see? Then try, I don't know what we're going to see over here on these results. Okay? But don't write anything yet. I'm going to do one of these sides with you. Okay? I'm first going to do length of LM. That's the one I'm going to do first. This is a good way to write it with a little subscript there. Length of LM, so I know which side I'm talking about. So that means I got to do square root x2 minus x1 squared plus y2 minus y1 squared. And let me just say it again. This is just the Pythagorean theorem with delta x's and delta y's for the sides. So LM. Now this is interesting. You got to organize yourself a little bit, because I'm going to label these x1s and x2s, but it'll only be x1s and x2s for this line. Then I got to switch the labels. So I'm going to go over top. LM. So this is going to be my x1, and this is going to be my y1, and this is going to be my x2, and this is going to be my y2. See, those are going to change as I do each line here. So x2 minus x1, where were we? Negative 2 minus 3 squared plus 5 minus 0 squared. Let's just check that. LM. Negative 2 minus 3 is 5, yeah. 5 minus 0 is 5, yeah. I think it's right. Length of LM equals square root negative 5 squared plus 5 squared. I get LM is 25 plus 25, which is square root 50. Now I must tell you that my senior math experience tells me, just leave it at square root 50. It's perfect. It's beautiful. Square root 50. It's not rounded. It's not a decimal. Not anything. Grade 10 when I get it to 1 decimal place, all right? I'm reluctant. I'm reluctantly getting the decimal places. I like square root 50. I like how it looks. It's nice and tidy. But I'll do it. Square root 50, I get 7.1, because they said to 1 decimal place. All right? Do you have any questions on finding length of a line segment? You try it now. I'm going to do it. I'm not going to skip over it, but now you try. Let's not wait around until tonight to see you don't know what you're doing here. Take a second and try and do mn and ln. And we got to compare them all when we're done. I'm going to have to go to a new page because I'm going to run out of space here, I think. Well, I'll play around. While you're working, I'll play around and see if I can fit it in, but I don't think I can. Yeah, I'm going to go back and forth to another page. So you just keep watching up. You try it, and then you keep watching up. mn, x2. You try it, then look at mine. Question? Because you're finding the difference between those two y values. You're finding the delta x. You're finding out how far the x went over, and then how far the y went over. It might help to draw, for LM, to draw this little triangle here. This little right angle triangle. And by doing -2 minus 3, you're finding out this length here, which is -5. Well, it's -5. That negative bothers people, and it should, but we're going to square it anyways. Yeah, so then the negative, if you want, it went left 5. But then we go, well, I don't care about that it was negative, so I square it to go, I just need the squared value.
It doesn't matter which one is x1 or x2.
No, because if somebody else did the question the opposite way, they get +5, but when they squared it, they get 25, the same as you, so it ends up being okay. It works out, yeah? That's a perfect concern here, but as you do it, you'll find out, oh, that doesn't matter that much. Oh, no worries. Thank you very much. I did MN. Now I got to check to see what my last one was. I forget what the last one is. I did LM. I did MN. Now I need LN. Yes. LN. I'm not trying to rush you. Do you need more time to try those 2 lines? Who needs more time? Yeah? Yeah, take some more time. I want you to practice it right now to convince yourself you got this under control before you go try the homework. 8 and 1. -8. -1. Yes, 64. I'm just checking some answers to make sure I got everything right before we go back and do C. Destiny. What's that? Should it be in units? The answer is yes, except this one doesn't give units. So if you did want to answer, then you just say, we usually just write the word units. As if to say, whatever it is you're talking about, see that's 1, 2, 3, 4, 5, 6, whatever, if you're talking meters, it's meters. Centimeters, centimeters. So we're bad in math for leaving that out sometimes, for not writing units there. But you're right, we really should write units there. And all we're saying is, I don't know what we're talking about, but you better put something there. It's centimeters, or it's meters, or it's kilometers, or whatever you're doing. Yeah, good. More time? Okay, well, the last one shouldn't take us long. What type of triangle is this? First length was 7.1, then 6.7, then 8.1? Scalene. That's getting closer to the kind of things we're actually trying to do this chapter, is actually go, let's look at a shape, let's do some analysis, and figure out what type of shape we're talking about. And so I'll write here, scalene. So fair warning, this chapter jumps at some point. Some basic calculations that with practice you hopefully will get really good at, but then some thinking coming later. Any questions there? There's your homework, 87, 1 to 5, 7 to 9.